a metal and a polyatomic ion, or polyatomic ion and a nonmetal. So a polyatomic ion is just simply multiple atoms put together with a charge to create an ion. So it's a multiple atom ion. And we treat it like a unit. Okay. When we name these, we use different endings of ATE and ITE to help us differentiate the number of oxygens that are added onto our polyatomic ion. So most of the time, a polyatomic ion is where an oxygen has been bonded to one of our other nonmetals. Not always the case, but mostly. So if I look here, I have this pattern of oxygens from most oxygens to least oxygens with a polyatomic ion. So ClO3 is chlorate, the ATE ending. If I have one more oxygen than chlorate, with ClO4, I have perchlorate, keeping that AT ending and adding the per on the front. Going back to chlorate, if I have one less, I go from ate to ite, so chlorite. And then one less than that is hypochlorite. So that has the prefix and the ending. So just something to be aware of, the number of oxygens can dictate my ending. We can also note that acetate can be written in two ways. Most of the time, C2H3O2 with a -1, or it could be written CH3COO with a -1. Now I talk about that they're treated like a unit. So when we put them into our chemical equations, there are parentheses around the atoms of it. So there'd be a parentheses here and here. This way, if we have 2 acetates, we would put a 2 after it, and that shows that we have 2 of this entire thing. Otherwise, if we were to not use one, we'd have C2H3O 2 and 2, and that would look like we had 22 oxygens when that's not the case. We have 2 acetate ions. So something to be aware of as we're going through, and we'll look more at this, and you'll see this more in class. But if you look down to the bottom here on how to name them, if we name them here, we say we have a metal name and then a polyatomic ion name. So here we see that we have 3 elements. So anytime we see that we have more than 2 elements, that means that something must be a polyatomic ion. Also, we have the parentheses here. That also tells me that I have a polyatomic ion. So I name it just like before. I take my metal name, which was calcium, and then I look for my polyatomic ion on the chart. So you all have a chart with your polyatomic ions, and we look for OH. We also notice that there's a 1 down here, so it'll be under the column. It has a -1 charge. So I look for that OH, and OH is hydroxide, so a hydrogen and oxygen bounded together. Okay. We can go the other way too, where we are given the name and we look for it. So let's do these 2 together. So NH4, I look on my reference guide and I see that NH4 is ammonium. And that is the name of my polyatomic ion. It's in my parentheses. And then my nonmetal is sulfur, and that becomes sulfide. Okay, so just like before. Then going the other direction, I have calcium. Calcium is a group 2 element, so I have a charge of +2. And acetate, C2H3O2, is a polyatomic ion, so I put parentheses around it, and it has a charge of -1. So now, just like before, I crisscross my charges down, the 1 all the way to the outside of my parentheses here, the 2 all the way outside my parentheses there. And that means that I have calcium, parenthesis, C2H3O2, 2. So I have 2 acetate ions, 2 of them, that have an electrostatic attraction to my 1 calcium ion.